Hello and welcome to the computer science team. My name is Miss Williams and I'm the subject lead, and I'd also like to introduce Mr. Bowen, who is a computer science and business teacher. Computer science course that Herts and Essex offer follows the AQA 7517 syllabus, and the programming language that we use is Python. The course is linear and the final marks are composed of 2 exam papers, paper 1 and paper 2, plus a non-exam assessment which is worth 20% of the course mark. Paper 1 is a programming paper and focuses on programming basics and concepts. There's structured programming and also includes object-oriented programming. We also cover data structures, algorithms and computational thinking concepts. The paper also requires you to program an unseen problem and to also code solutions to a program provided to you at the beginning of year 13. In paper 2, it focuses on data representation, computer systems, computer organisation and architecture, ethics and legal issues, and a large component of databases, big data and functional programming. The third part of the course that we cover is the non-exam assessment, and this focuses on a coding project which is designed and developed by the candidate, and it may focus on providing a solution to a problem, or alternatively can focus on an investigation which is of interest to the candidate. To complete this, they need to complete a program and develop a solution to the area that they are covering. As part of this non-exam assessment, it is a requirement that students complete an analysis of the program that they are designing. They design it, they code a technical solution, in our case using Python. They test the solution and conduct an evaluation. To study A-level computer science, it is a requirement that students should have completed a GCSE computer science course, achieving a grade 6 or above, and also that they have achieved a grade 6 or above in GCSE mathematics. It is not sufficient for a candidate to have completed a GCSE ICT or iMedia qualification, as this will not prepare them sufficiently for the A-level computer science course.
So what are the key topics covered in computer science A-level?
Okay, so the topics that we've got very much build on the GCSE course that we have. We cover programming using Python as our programming language, and we enable you to develop key skills in that area. We then cover the fundamentals of programming, and we cover basic skills and concepts, and then we also teach students in the programming how to use subroutines. We develop those skills along with functions. We also develop the use of global and local variables, and then we also spend a lot of time working on codes that are provided by the exam board, and we ask students to develop solutions to those. Finally, in year 13, we work on object-oriented code, and again we use exam board materials, and we work through those and create our own solutions to those. In the theory side, again we're building on the GCSE, and we're looking at algorithms and how they work and how they're applied, computational thinking. We also look at things like data representation, and also look at computer systems, computer system organisation, and we also think about networks, and then we also have quite a large unit on databases, because obviously that's a key component of a lot of large organisational data systems, and then we also look at functional programming. As you're aware, within GCSE we have a module on ethics, and that is slightly more developed at the A-level, and we look at moral, legal and cultural issues. The other area that we also focus on is the development of your non-exam assessment, which is part of your final mark and is a piece of work that you analyse, you design and you develop.
So what does the assessments involve? Is it just exams or is there also coursework?
That's a really good question. We use the exams to provide paper 1 and paper 2, and the paper 1 is really focused on programming. Again, we're given something called skeleton code by the exam board, which just basically means that they give us an incomplete piece of code and we develop solutions to that. So that is something you would do in the exam. You also have an unseen program that you have to write, and there's also a theory element as well, so dealing with algorithms and also developing some of the functional skills that you would need in programming. And then the paper 2 is really the theory paper, which deals with databases, data representation. We also have networks and computer systems, logic and Boolean algebra is also covered in that as well. So the paper 1 and the paper 2, that is 40% of your overall mark, and your non-exam assessment is a piece of work that you'll work on from the end of year 12, and that is a 20% component of the final exam.
What sort of grades do you need to study this subject?
We recommend that you have at least 6 in GCSE computer science.
Do I have to have studied computer science at GCSE?
We really think that that's beneficial for you. In talking with my year 12s and 13s, they've said that they feel like the A-level course is actually building on the GCSE course. So in fact, it turns out to be a 4-year course. So they strongly recommend that you have done the GCSE computer science course.
So what's different from the A-level course to the GCSE course?
The theory is learnt at a much deeper level. We also cover things in more detail like searching algorithms and sorting algorithms. We also look at things like Dijkstra's algorithm, travelling salesman problems. We also look at some mathematical concepts like vectors, which you don't come across in GCSE. We also look at trees as well, graphs and trees. So that's much more detailed, and also on the paper 2, the area that we look at in much more detail is logic gates, Boolean algebra, and also we find that the databases module is very extensive and much more detailed than at GCSE level.
Is there any equipment that's necessary that you might need to buy?
You can use the PCs that we have in our computer science suites. However, we would recommend that you have some device at home that will enable you to program. So perhaps a desktop PC or a laptop. They're not a prerequisite of being on the course, but it is something that you might find really, really useful. Okay. We provide you with textbooks, and we also provide you with other course materials as well. So you don't have to fund those, that's provided by the school.
Okay, would there be any trips or visits?
Obviously at the moment we haven't been able to run any trips, but we have been planning to run a trip to Bletchley Park. We have previously run trips to computer science days that have been held in London for different magazines like Wired, where they've been offering those. And then we also recommend students do the cybersecurity activities as well, like Cyber First.
Okay. So what sort of careers could doing computer science at A-level lead to?
So computer science allows you to go into such a wide area. It's a really, really well respected degree. We've had students leave from Herts and Essex and go and do A-levels in physics, computer science, mathematics, chemistry, at some very prestigious universities. We've also had students take up apprenticeships in cybersecurity, And we've also had students take up apprenticeships in pharmaceutical research. Equally, we've also had students that have gone off and decided that they wanted to study completely different subjects, but they have found the computer science course really, really useful. For example, teaching. We've had students go off and study teaching as well. The other thing that we have had students interested in and be successful in is games design as well.
Okay.
Okay, so Leon, I'd like to ask you, what have you found most interesting about your studies so far?
Well, for me, I personally find the coding aspect of the computer science A level to be the most interesting, just because of things you can do with it and the freedom you get with it. For example, at home, I do lots of projects, each getting more and more interesting. My last project, I've made a robotic arm I can control with a joystick, which I found very, very fun to make. Coding and just computer science also combines very nicely with other subjects. For example, for me, maths and physics. With physics, I've made several things. For example, a pendulum, like a simulation for a pendulum that can swing. That has expanded my knowledge on the simple harmonic motion topic, which is very good. And like just the other day, I've made a integration piece of software that integrates for you. It's only an approximation, but it's very fun to look at. So in computer science, you also learn how things work. For example, a computer, or how a computer can connect to the internet, which I find really interesting because it's just how everyday items interact and stuff like that.
And what I've really liked about watching you develop as a computer scientist is how you're applying your work to your physics type projects with the pendulum, with the arm that you've done, the robotic arm. And also the other thing I've really enjoyed is seeing you and David working together developing your pieces where David's got the printer that he can put components together for you. That's been really fascinating to see that develop. So can I just ask you, how was the GCSE to Year 12 transition for you?
Oh, it's probably the easiest transition out of all my subjects. The A-levels, just like you said, entirely built off the GCSE, which does mean that you need to know the GCSE syllabus inside and out. But yeah, apart from that, it's been the smoothest I've had out of all my A-levels.
Okay, I think that's really key. You saying that having that GCSE foundation's really, really helped you. Yeah. What advice would you give to a Year 11 student considering taking transitioning from GCSE computer science into the A-level course?
So, as you probably know, there's a transition pack available to the students who may want to do computer science. This I find is very useful in developing your knowledge of computer science syllabus, which, well, like you said, the GCSE syllabus is entirely necessary. Also, you need to make sure that you enjoy programming, so much so that you just do random tasks in your own time, like me with the robot arm, etc. If you weren't taught Python at your secondary school, because Python's what we're taught here at House in Essex, if you weren't taught Python at secondary school, it'd be in your best interest to go over the basics at least before you do this in your A-level. But as someone who came from Visual Basic, it's probably one of the easiest things you're going to be doing at your A-level. Yeah.
I think that's a really good point, because we do have students that come here that have not learnt Python, but I think because the coding constructs are so similar, it's quite an easy transition into Python. But I think that's a really good point that you made, that you can learn Python and those constructs, and then you can start to pick up the language. And obviously, as we go through the course, we do scaffold it, so we teach you a lot of the constructs as you develop. And also, I think it's really important that you are an independent coder and that you do like to go and find your own coding projects to do yourself. So I know we've talked about this before, but tell me what you want to study in the future.
Well, like previously said, at uni I want to do computer science engineering, which is sort of a 50-50 split between engineering and computer science, which just takes everything I find interesting, just combines it into one course.
Mm-hmm.
Yeah, I think that's what I want to do for.
Do you have any objective of what you would do in the future with that degree?
Well, I like to make things, so being some sort of engineer probably be my end goal. But with computer science, it allows me to just do so much more. For example, with Arduinos or Raspberry Pis, I can get things to do things just with a bit of software in, and it just makes everything so much easier and just increases things I can do.
Because I know I've spoken to you about this before, but I definitely can see a career for you in doing some medical robotics, because I think that's the type of thing that you're really skilled in. And your development of your arm has been really impressive to watch. So are you glad that you chose the subject?
Oh, definitely. It's just worked so well with all my other subjects. It's allowed me to do so many interesting things. It's just been a fascinating subject, really.